In this section, we are going to be discussing multiple spanning tree, which is 802.1s. Multiple spanning tree is backwards compatible with traditional spanning tree, which is 802.1d. It is also compatible with rapid spanning tree, which is 802.1w. And in fact, it operates exactly like rapid spanning tree, with the addition that it allows separate spanning trees per VLAN group. This allows you to create different topologies and map different VLANs onto those different topologies so that you can load balance between links. Remember, spanning tree works by breaking loops by putting ports of particular links inside a blocked state. This will actually make that link inactive, more or less. Multiple spanning tree tries to make use of that link by having some VLANs with that link active and other VLANs with that link blocked. Note that a particular VLAN can only be mapped to a single multiple spanning tree instance. So let's take a look at the end goal. This diagram shows us what we'd like to achieve. We have VLAN A, which is the blue VLAN, and VLAN B, which is the yellow VLAN. And we have these three switches at the top, these two down here, and nodes. Now, you could put the switch on the left in VLAN A, you could put switch on the right in VLAN B as the root of VLAN B, and the switch on the left as the root of VLAN A. And what that does is, because spanning tree is going to end up blocking one of the ports and disabling one of the links, is VLAN A ends up using the link on the left from the switch at the bottom to the two distribution switches at the top, and VLAN B ends up using the link on the right from the switch at the bottom to the distribution switches at the top. So you kind of load balancing between the links instead of having all of them on one. Remember though that for our campus network design, we recommend that the complexity of maintaining this kind of configuration usually does not give that much benefit for a campus network. Your bandwidth constraints are not likely to be on the inter-switch links, they are likely to be on your internet link. However, we shall go into the details of how multiple spanning tree works so that you can understand the different concepts. So one thing to start with is the MST, multiple spanning tree instances, or MSTIs. So groups of VLANs are mapped into particular spanning tree instances. These instances represent alternative topologies of forwarding paths. You must specify a route and an alternative route for each instance. We've also mentioned that a VLAN can only be in one MSTI. MST region, a multiple spanning tree region, is a collection of particular MSTIs. And switches are members of a region if they have the same set of these attributes: the configuration name, the MST configuration name, the MST configuration revision, and those MSTIs, the instance to VLAN mapping. So inside the BPDUs, you have a digest of these attributes so that the switches can quickly compare if this BPDU belongs to something which is in the same region as the switch or in a different region. Again, one region usually is sufficient for even very, very large switched networks where you have lots and lots of switching with very little routing. The next concept we need to talk about is the common spanning tree, or the CST. This is defined in the 802.1q standard. Remember that the 802.1q standard specifies VLAN tagging, how tagging should work. But it also specifies that there should be a common spanning tree for all VLANs, and this is the CST. So in order to operate with other versions of spanning tree where you have a single spanning tree, multiple spanning tree needs that common tree that contains all the islands, including other MST regions. So that spanning tree instance for the entire bridge network is presented regardless of the number of VLANs or regions and everything. So that is a common spanning tree. Now, internal to each region, you have what is called the internal spanning tree. and within each MST region you might have multiple spanning tree instances. Now, instance 0 is the special instance known as the internal spanning tree, and it extends the common spanning tree into this particular region. Inside instance 0, MSTI instance 0, you will see the links which are inside the region, and then you will also see the links which exist inside the common spanning tree outside the region. So the switches within a region will see that topology inside instance 0. It also has the side effect of it presents this entire region as a single virtual bridge to the CST outside. So inside you can see everything inside the CST, but outside the region you just see one bridge. This is a diagram that shows how this works. Outside is what is the common spanning tree, and in the common spanning tree there's just 3 bridges. There's the one at the bottom, and then the 2 regions are seen as individual bridges. Now inside each region, inside each MST region, you have the MSTI instance 0, which is the internal spanning tree, and you have the details of the connectivity, but as well you can see the other 2 external bridges, the one for the switch which is not inside any one of these regions, as well as the one for the other region which is seen as a single bridge, and the same thing for the region on the left. So we're going to have a more detailed example, and this diagram is taken from Brocade, which acquired Ruckus and is now owned by somebody else. But the idea is to get into some detail of how these links would look like inside the different spanning tree instances. At the top you have switch 1, a switch which is outside both regions. That switch could be a switch that is running rapid spanning tree or even traditional spanning tree. Then you have region 1 and region 2, each with their set of multiple spanning trees inside. Now, if you look at the common spanning tree first, according to this topology, there are 3 switches. There is switch 1, there is region 1, and there is region 2. And note that switch 6 of region 1 is connected to switch 4 of region 2. There is that link. There is a loop inside the common spanning tree. Now, because of the common spanning tree, you will end up disabling one of the ports depending on priorities and things, but you'll disable that port between switch 6 and switch 4 between the regions. Now once that is done, within each region you need to now also break the loops. So inside region 1 you have the switch at the top was picked as the root bridge, and therefore that link from switch 4 going up will be placed inside a disabled state to break that loop. Inside region 2 you have again another spanning tree, and the link on the right is also going to be disabled to break that loop. So you have the common spanning tree that is running outside, and you also have the spanning tree that is running inside. We've just looked at an example of just the IST. We've not looked at different spanning trees. Remember that you can create inside within each region more instances where some VLANs have different links disabled instead of the links that we've shown inside these diagrams, by just changing which bridge is the root and the alternate route, and then mapping particular VLANs to these other instances. So if you're going to design something like this with multiple spanning tree and you plan to try and load balance using these VLANs, there are some design guidelines that you should think about. The first is you need to determine the relevant forwarding paths and to try and distribute your VLANs equally into instances matching these topologies. Of course, you need to take into account how much traffic a particular VLAN carries, not just the number of VLANs, but how much traffic you expect on that particular VLAN. Then you'd need to assign different route and alternate route switches to each instance. And then you have to make sure that within a region, all switches match the region attribute. Again, it's more likely that you'll have just one region. Now, the IST, the internal spanning tree, carries all VLANs which are not mapped onto specific instances. So do not assign VLANs to instance 0. It will be used by the internal spanning tree, but also if you have not mapped a VLAN to a specific different instance, then that VLAN will use the IST, the internal spanning tree. So you should not try to assign VLANs to instance 0. Some switch vendors will actually prevent you from doing it, but some, it's a silent configuration error.